Hi out there. My name is Josh. I'm part of the Morrison Planetarium team at the California Academy of Sciences. We are here for our Many Ways to Move Mars Edition project. So, if you clicked on this is a way for us to explore the surface of Mars in a pretty awesome way. What you want to do is go to trek.nasa.gov. We'll include that URL in a handy spot. And once you've gone there, you should see a web page that looks something like this. So if you're checking out trek.nasa.gov, you'll see a rectangular version of Mars. And I'm going to put myself right back on there so you have a chance to see me too. When we're looking at this, though, there's a tutorial. It's a great way to learn more about the software. But for today, I'm going to skip that. And I'm going to turn this rectangular version of Mars into a more normal looking globe by going down here to this little globe icon marked projections and clicking on 3D globe. And with that, all of a sudden, Mars looks a lot more round, more planet-like. I think this is the much cooler Mars to look at. So looking around here, we have a very high-resolution map of Mars, and our mission is to find a way for our theoretical spacecraft to land on the surface and to move around from one place to another. Mars is a planet with many different kinds of surfaces on it, and that can pose a big challenge. If I wanted the easiest surface to land and move around on, I might pick a big, flat, open spot like this. That looks pretty easy to navigate. It's a big, flat rock, very easy to drive on. But if I wanted to find a more scientifically interesting target, I might aim for other regions, maybe regions like this. And this is a really cool one on this giant crack-like canyon structure called Valles Marineris. If I zoom in, I think you can see why I think this is so cool. There are all these interesting fractures, giant, steep, sandy, and rocky mountains, even this strange mesa-like structure I'm spotting right here in the middle. There's a lot of cool stuff happening here. But let's say I wanted my spacecraft to land on the surface and to move around. Well, that could pose a challenge because this isn't just flat rock. There's a lot of interesting things going on. So looking around here, if I wanted to imagine some kind of rover that can get from one side of this little valley to the other, I would need to think carefully about not only the path I take, but what kinds of wheels I would send on my rover. If I sent big, heavy metal wheels, they might be tough enough to endure some of these pokey rocks, but they might get stuck in these loose, sandy areas. So I think I might send something with light wheels with big, heavy grips, like tread, that might be able to move them across the sandy stuff and still be strong enough to go across these rocky things. But that's going to be different depending on which part of Mars you land on, because my light wheels might not work on the sides of these giant mountains. So figure out where you want to go on Mars in order to answer your scientific questions and what kinds of wheels would work best for you. Good luck!
Hello, my name is Mary and I work at the planetarium at the California Academy of Sciences. And welcome to Many Ways to Move, Enceladus edition. NASA Treks has a few different options when it comes to icy moons in our solar system that you can explore. Today I'm going to look at Enceladus, which orbits Saturn. First, we're going to start by skipping the tutorial, though if you would like to explore this yourself, that's a great first step. And then I'm going to go down here to the bottom left, click on this little globe right here, so we can see Enceladus in 3D and not just in a flat map. So let's take a look around this moon at what kind of surfaces it has. I see some areas that look a bit cratered, some areas that look like they have little cracks or something, and some smooth areas, and some areas that look kind of icy, and some that look kind of snowy. And let's think about what kind of robot explorer do you think we would need here? With our other two videos, we've explored rocky worlds, Mars and the moon, where often we use rovers or vehicles with wheels. Would you want to use something similar here? What sorts of challenges do you think a rover with wheels would have? And a lot of these areas, like I mentioned, do look maybe kind of icy or snowy. So I guess if you did want to use some wheels, you might want to use some with more tread or maybe something more like a snowmobile. But the most exciting part of Enceladus, I think, are these areas of blue stripes. Those are showing us areas where we think there's a bunch of liquid water underneath the ices. And we even see some water vapor coming out of this moon in geysers. So, Enceladus brings up an interesting question. What kind of robot explorer could we send to one of these moons to explore more than just the surface? Would we want to send a drill, a submarine, something else? What do you think? Well, if you have a chance, I encourage you to check out Enceladus yourself and come up with some ideas for what robot you would want to send. Thanks for joining me and happy exploring.
Hi, I'm Bing. I'm with the Morrison Planetarium at the California Academy of Sciences, and this is Many Ways to Move on the Moon. Now, we've already seen a few spots on the moon, and in fact, 50 years ago, more than 50 years ago, people walked on the moon during the Apollo program. But NASA and other space programs would like to go back and look around some more. So we're going to explore the moon using a computer program from NASA called MoonTrek. And you can download this for free at trek.nasa.gov. This is the opening screen. I'm going to skip a few steps to get right to a globe that shows us what the moon looks like, the way we're used to seeing it. So there's a 3D globe of the moon right there. And this is all based on actual photographs of the moon's surface. Now, when we go back to the moon, we'll probably send both humans and robots to explore different regions. What kind of robot would you send? How would it get around? That might depend on where you send it, because the moon has lots of different terrains, and some ways of getting around work better than others on certain types of ground. So far, all robots that have been sent to the moon have landed on large, flat, dark areas that don't have too many rocks or mountains or craters. And that's great because those are the safest areas to land. They've all been sent to the moon and they had one thing in common: wheels. Why do you think their designers thought that would be the best way to get around? Well, the big flat areas on the surface of the moon are the safest ones because there aren't a lot of obstructions that you might run into or fall off of. Now, what if robots landed not on one of these nice, safe, flat areas, but in some place very rocky or steep, places where there are mountains or lots of craters? Some of those craters have very steep sides that are hard to climb. Would wheels work there very well? Could a robot climb a steep hill? The kind of surroundings where a robot goes may depend on how it travels from one place to another. Can you think of ways other than wheels that might be good on rough, rocky surfaces? Some vehicles, like tractors or snowplows, use treads instead of wheels. These make contact with the ground over a larger area and provide a better grip over rough or sandy surfaces. But they might not be able to make sharp turns to get around things as well as wheels can. Can you think of a robot design that would work on all types of surfaces? Or would you make different ones that would specialize in different surroundings? The moon has lots of hills, rocks, and deep craters that would be a challenge even for human explorers. Can we even design a robot without knowing exactly what kind of place it's going to go to? Use your imagination and a program like MoonTrek so you can get a better idea of what the moon is like up close. See if you can think of some clever and creative ways to explore our nearest neighbor in space. Happy exploring!